Hello there guys, welcome back to another video of Computer Vision with PyTorch series. In this video what we'll be doing is, we'll be creating test and train data loader. But before creating train and test data loader, let us revise what we did in our previous video. In our previous video, we imported FashionMNIST dataset from torchvision and then we visualized the dataset using matplotlib. Now what we're going to do in today's video is that we'll be creating train and test data loader. Data loader are also called batches. So let us understand what does data loader mean. Data loader are tools or utilities designed to streamline and optimize data retrieval and processing. So what this means is that, currently in our train dataset, we have 60,000 image tensors. This is one image tensor, and we have such 60,000 image tensors with their respective levels. So the problem is that when we send 60,000 image tensor through our model during training phase, our memory will be computationally inefficient. Our memory cannot handle the computation that are happening behind the scene in the hidden layers. So what we want to do to solve this problem is that we want to create batches of our train data. So what I mean to say is that, suppose we have 60,000 training data, right? So in one batch, we want to keep 32 image. So for example, we have batch 1 where we want to keep 32 image. Then we'll have second batch where we want to keep 32 image. This way, what we're doing is that in one iteration, we're sending just 32 image tensors to our model. And in this way, our neural network also has more chance to update its gradient per epoch. So this will solve the problem of computationally inefficient way that we just discussed before. So let us revise why we need data loader. We need data loader because our model cannot handle 60,000 image tensor at once. And to solve this problem, what we want to do is we want to create separate batch where in one batch there will be 32 images. So currently, what is the length of our train data? The length of our train data is 60,000. So in our train data, there are 60,000 images with their labels. So if we want to create many batches of our train data and in one batch, we want to put 32 image tensors and their labels, how many batches should we create? So 60,000 is the length of our train data and we want to create 32 batches. We want to create 32 image in one batch. So we'll end up having 1875 batches for our train data. And similarly, what is the length of our test data? Length of our test data is 10,000. And if we want to put 32 images in one batch, then we'll end up creating 312.5 batches of our train test data. So let us create data loaders. So now that we know why we need data loaders, why we need batches, and why can't we send 60,000 image tensors during training, so let us create our data loader. To create data loader, we need to import data loader from torchutils.data. So let us import our data loader from torch.utils.data, import data loader. So first of all, let us make our train data loader. And to make data loader, what we want to do is we have to pass several parameters to data loader method. And what we want to do is, first of all, we want to create train data loader. So the data set will be train data. What we're saying is that from the train data, make different batches. And in one batch, how many images? 32. And that will specify in batch size 32. What we're saying is we want 32 images in one batch from our train data. And we want to keep shuffle equals to true, because we don't want our model to learn the ordering of our images. We want our model to understand the patterns, but not the ordering. And in similar way, let us create test data loader equals to data loader. And the data set we have is test data. We want to create batches from our test data and the batch size would be 32. and we don't want to shuffle our test data because our model will not see test data, so there is no chance of memorizing the order. So let us run this cell and our data loader should be created. So let us check our length of our train and test data loader. So from previously we looked at the length of our train data loader should be 1875 and the length of our test data loader should be 313. So let us check if it has created the data loader correctly or not. Length of train data loader, and similarly we want to print the length of our test data loader. Test data loader. Okay, looks like this data loader method has created data loader correctly. The length of our train data loader is 1875 and the length of our test data loader is 313. Currently our train data loader contains 1875 batches. So let us look how the first batch looks like. So to look the first batch, what we want to do is we want to convert train data loader into iterable object. So iter train data loader. This will convert our train data loader to iterable batch, and then since we want the first batch, I will put next. This will return me the first batch, and in my batch there will be features and there will be labels. So I want to store features in train features batch, and then I want to store labels in train labels batch. Now let us check the shape of our train features batch and train labels batch. Let us print the shape of our train features batch and the shape of our train labels batch. So okay, the shape of train features batch is 32, 1, 28, 28. It is 4-dimensional, which means that the first dimension is batch size. In one batch there are 32 image, and 1 represents color channel, 28 represents height, and then this 28 represents width. Similarly, in train labels batch, it is 1 dimension, which means that for every image there is corresponding labels. So to end the video, let us extract one image from our train features batch and then plot using matplotlib. So I will do torch.manualseed 42 for reproducibility, as I want the same image every time when I run this cell. Now I will create a random integer. So to create a random integer, what I'll do is torch.randint, and I want integer between 0 to 32, so 0 to length of my train features batch, which will be 32, and I want size to be 1. This is train features batch, not train labels batch. Now I want to index through train features batch, and that will give me image, and if I index through my train labels batch, that will give me the label. So train features batch, and if I put the integer that has been generated by this line in this, that will return me one image tensor, so random int. And similarly, if I index through my train features batch and train labels batch, train label batch, and put the random integer and this will return me the label. So let me store in the variable image and label. So now what we want to do is we want to plot this image, and we want to put the title of that image as its label. So plt.imshow image.squeeze, because we want to add extra dimension. plt.title, so the title of that image should be the label. So label is just an integer, so I want to extract the actual label, which is something from this list. So I want to index through my class names. So let us do that in the plt.title class names, and I want to index by keeping the label. And also I want to put access equals to false to view the image clearly. So the image is of a t-shirt /top. So that was all for this video. What we did in this video is that we create a data loader because in our model we cannot pass 60,000 image tensor at once. That will be computationally inefficient. So to solve that problem, we created train data loader and test data loader. We've also extracted one batch from our train data loader and then extracted one specific image and then visualized using matplotlib. In our next video, what we'll be doing is we'll be creating a baseline model and then passing this data loader in our baseline model. So subscribe to the channel, and if you haven't accessed the playlist, please access the playlist and tune in for further videos. In the next video, what we'll be doing is we'll be creating a baseline model.